Good morning, guys. This is Anjani Kumar, Electrical Department, Nutrients Group of Institutions. I'm continuing my subject regarding Power System 2 for third year electrical students. But today, some of the students asked me about, so could you please explain briefly about each and every electrical machine? So that's where I'm doing this video. Definitely it will be used for power system also. This is for already completed machines, right? Already completed the machine subject for second year and all these things. So could you remind this one? So you know that energy neither generated nor destroyed. So you can transfer the energy from one form to another form. So basically what are the forms that we are getting in electrical system? In electrical system you have electrical form and mechanical form. So in electrical system what you are getting, what are the parameters that you are getting? So those are voltage and current. In mechanical system, so mechanical means rotation. So what are the parameters that you get? Torque and speed, right? So the voltage in electrical system, which is analogous to torque in mechanical system. The current in electrical system, which is analogous to speed in mechanical system. So that's why those are interlinked. So that's why you are getting in electrical system voltage and current, like generator. In a machine, motor, so you will get torque and speed. So you know the definition of a voltage and current. So what is a voltage? Voltage means the force required to move the electron from one place to another place. We can call it as a voltage. So the movement of electrons, we can call it as a current. Similarly, the torque, force required to move the linear motion into rotational motion, we can call it as a torque. That motion we can call it as a speed. So these are interlinked. These are the brief basic introduction for everything about voltage, current and all these things. So what I said earlier, so we can transfer the energy from one form to another form. So electrical to mechanical, we can call it as a motor. Mechanical to electrical, we can call it as a generator. We can also transfer the energy from electrical to electrical also, so that we can call it as a transformer. So we can easily transfer from one form to another form. Is it possible? Definitely not. We require a medium. So that medium we can call it as a magnetic medium. So if you want to transfer the energy from electrical to mechanical, first you should convert it into electrical to magnetic, after that magnetic to mechanical. So that we can call it as a motor. Right? That's why each and every electrical machine we have a magnet, either permanent magnet. Definitely you'll go for a permanent magnet. Right? So for a generator, so mechanical to magnet, magnetic to electrical, we can call it as a generator. Even transformer also, electrical to magnet, magnetic to electrical, so we can call it as a transformer. So in this video I just give a brief introduction regarding each and every electrical machine, like what is a generator, what is a motor, what is alternator, what is a synchronous machine, what is induction machine, like DC machine and AC machine. All these things, brief introduction you will get each and every machine, no doubt about it. If you follow the video, definitely you will get so this is the motor, how it will work, you know everything, right? So if you want to study each and every electrical machines, first you know the basic laws. So what are the laws? So if you know Faraday's law, Ampere's law, both are enough to define each and every machine. No doubt, those two laws are enough. So what is the Faraday's law? So what's the Faraday's law say? So Faraday's law comes from magnetic property itself, because I know, without a magnetic medium you can't transfer the energy, you can't operate the machine, right? So what's the Faraday's law say? Faraday's law states that rate of change of flux linkages will give voltage. I don't have any blackboard, So could you concentrate on my voice? So it will definitely give all the definitions, right? So what is the Faraday's law? Faraday's law states that rate of change of flux linkages will gives a voltage, will generates the voltage. What it means? If you want to generate the voltage, definitely required change in flux. That's why each and every machine without a magnet, no machine is there. Change in flux required to generate the voltage. The first law is second law. What's the Ampere's law? So Ampere's law states that when current passing through the conductor, definitely there will be a magnetic field around it automatically produced. When a current in the conductor, magnetic field will be produced, or else ఒక magnetic field లో you place a conductor, definitely the current will flow. Those two laws are enough. So what are the laws? The first law is a Faraday's law and second law is a Ampere's law. So if you know that these two laws, you can define each and every machine. There is no doubt about that. Right? Shall we go for each and every machine? Okay. Okay. Go for a generator. So what is a generator? So generator means it converts a mechanical energy into electrical energy. Definitely I have a magnet, north pole, south pole. There will be a flux flowing from north pole to south pole, and I'm having a conductor between north pole and south pole. Yes. What's the Faraday's law? If you want to generate a voltage, definitely change in flux required. If you want to get a change in flux, you should rotate. I have a magnet, and between the magnet I have a conductor. Right? If you want to get the change in flux, you should rotate a conductor or else rotate a magnet. Magnet means field. If you rotate a conductor also, you will get the change in flux. If you rotate the magnets also, you will get the change in flux. At least one should do in order to generate the voltage. If you rotate a magnet, so we can call it as a DC machines, a DC generator, DC motor and all these things. If you rotate a conductor itself, definitely if you rotate a conductor, making the magnetic field constant, you will get the change in flux. Or else, if you rotate a magnet, you also get the voltage. Those type of machines we can call it as AC machines. So this is very, very important. Definitely you will get a question. So what is the difference between DC machine and AC machine? Right? Now, I have a magnet and I have a conductor. So what is a generator? You are giving a mechanical, you are getting electrical. Right? So conductor is there. You are getting conductor starts to rotating with mechanical energy. So my conductor starts rotating. So when a conductor starts rotating, it will cut the main field flux. Is there from north to south pole? Different points. Definitely you are getting different fluxes. So the change in flux will produce the voltage. You are giving mechanical, you are getting electrical according to the Faraday's law. Right? So you are giving mechanical means you are rotating your conductor. So whenever it starts rotating your conductor will cut the main field flux in different points. It will get change in flux. So that change in flux we can call it as a voltage. So generator definition over. So giving mechanical, you are getting electrical. So that is a concept of generator. So why my field is going to be excited? Another question. So without excitation, there will be a north pole, south pole. You are having simple minimum flux between north and south pole. These flux are not sufficient to develop more voltages. So if you want to develop more voltages means you need to require more flux. So when the more flux will be happen, you need to excite a magnet. So when you excite a magnet even more, definitely you will get more flux, more rotation, more number of change in flux, you are getting more voltages. Right? So definitely depends on excitation. The DC generators are series generator, shunt generator, compound generator. So the basic things, you know everything. Alright? In a shunt generator, so what is the critical speed? What is the critical resistance? So that is another important concept. We'll discuss what is a critical speed, what is a critical resistance. Alright, so what is a critical speed? Now, critical speed and critical resistance you will get in a shunt generator. That means excitation that is parallel to the generator itself. So what is the basic formula for generator? You are giving mechanical energy. Mechanical energy will give to the generator, will get a voltage. That means what is the formula? E is equal to, what is the voltage? V plus IA RA. I don't have a blackboard, you just listen. E is equal to V plus IA RA. V is nothing but developed voltage. IA is magnetic current flowing through that load. RA is internal resistance of the generator. In a DC machine, you will get what type of energy? AC energy. So how it will be converted? Through a commutator, we are getting a DC. You know everything, but I am giving brief introduction each and every electrical machine. So what is the function of a commutator? Commutator will act as a rectifier. So what is a rectifier? It converts AC to DC. First you are getting AC, then it converted to DC with the help of rectification. So you'll get rectifier. So what is DC to AC? So we can call it as an inverter. So what is a regulator? Fixed AC to variable. You know about regulator. Varying AC supply, varying speed, varying AC. So that we can call it as a regulator. So what is a chopper? Fixed DC to variable DC. We can call it as a chopper. All these things will get in power electronics. I think this same you will get power electronics. So that is the basic concept of a generator. Okay, in the next class. So I think the time is 15 minutes enough to create such large size videos. So definitely in the next class we'll discuss about motor, how the motor will work, and what is a starter, why you need starter to start the motor, and after that what is the function of AC machines, how this rotating magnetic field will develop, how the induction motor will work, why can't you apply a DC to induction motor. So what is the how alternator will work, how the synchronous motor will work, on all these things. In the following videos I'll clearly explain. You just listen my voice, that's enough. But you already completed your machine, so that's why it will be very useful for you guys. Thank you very much. Stay home, stay safe, and make your surroundings also safe. Goodbye.